Hi everyone. For 11.3, we're going to take a look at some two-dimensional figures or actual shapes. So far for geometry, we've been focusing on the basics, like point, line, plane, angle, things like that. We're going to get to some actual shapes. We're going to talk about the most basic shapes today: circle, triangle, rectangle, those types of things. And one of the things we're going to focus on is finding the area of the shape. Now, an area of a two-dimensional shape means how much space it takes up. And you're talking about flat space. You're talking about a flat shape, so you're talking about flat space. Now, the perimeter of a shape means the distance around it. So for most shapes, you can do it by just adding up the lengths, adding up the sides. If you have a rectangle or a triangle or even a 5 or 6-sided figure, just add up all the sides. You've got the perimeter. Now, since the circle doesn't have straight edges to add up, we actually have a different name for it, but it's the same concept. It's the distance all the way around the circle. We call it circumference instead of perimeter. So let's start with a square and a rectangle. Now, area of a rectangle, this is one of the easiest formulas to use. Area is length times width. And the perimeter of a rectangle would be 2 times the length plus 2 times the width. So let me give you a quick picture just so you can see where this comes from. Here's a rectangle down here, and let's say we'll call this side L and this side W, length and width, whatever the numbers are, 5 and 2. So the area, you just multiply them. If the length is 5, the width is 2, the area is 10, 5 times 2. Now for perimeter, I said we're going to add up all the sides. So you have to realize for a rectangle, this is also a W over here, and this is also an L up here. So when you add them up, you have 2 L's plus 2 W's. That's where that formula comes from. Now, a square is actually even easier. If you have a square, all 4 sides are the same. So instead of calling L and W, we just call them all S. S, 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 S. And when we do the same things for area, when you do length times width, you get the same number, side times side. So we just say side squared. And same for perimeter. Instead of saying 2 W's plus 2 L's, they're all the same. We just have 4 S's. So the perimeter is 4S. So finding area and perimeter of a square or rectangle is usually a very simple question. But I'm going to show you an example that's a little bit tricky. So let's find the area and the perimeter of this rectangle right here. Now, the reason I said this is a little tricky is we don't know how long the sides are. And because it's kind of angled, we can't just like count squares and figure out how long it is. What we need to do is remember something from Module 10 and do the distance formula. So let's say I'm going to find this side first, right here. And to do it, I'm going to use the distance formula. And the distance formula, it's that big square root one. It's x2 minus x1 squared plus y2 minus y1 squared. And let's use this point B up here, the 4 and the 3, as x1, y1. And let's use this C down here, the 5 and the 0, as x2, y2. So what I would have for x2 minus x1 is I would have 5 minus 4 squared. And for y2 minus y1, I would have 0 minus 3 squared. Now remember, you're welcome to use a calculator for this work, it's fine. But what you end up with is 1 squared plus negative 3 squared. That ends up being the square root of 10. You have the 1 plus 9. Negative 3 squared is a positive 9. Remember, anytime you square a negative number, it's positive. So 1 plus 9 is 10. Now, I'm not going to put it as a decimal. I'm going to leave it as the square root of 10 for now. What I'm going to do instead is I'm going to now find the bottom. Let's find this side down here on the bottom. And to do that, we'll just use the 5 and the 0 as x2 and y2 again. To do that, let's say instead of these two, let's use point D as our x1, y1. And if I use the same point C as x2, y2, I'll find the distance between those two sides, which will give me the length of the bottom side of the triangle. So this time, we have x2 minus x1 will be 5 minus negative 1 squared. and y2 minus y1 will be 0 minus negative 2 squared. So this time, both of those minus, remember when you subtract a negative, it actually turns into plus a positive. So both of these are going to turn into pluses. And we have 6 squared plus 2 squared. That would be the square root of 40. 36 plus 4. And I'm going to leave it again for now, because what I actually found is my L and my W. Remember, we call the two sides of our rectangle L and W, and it doesn't matter which one is which. One of them's L, one of them's W, it doesn't matter. So let's say that my square root of 10 is L, and my square root of 40 is W. See, now I can do that was the hard part. This is the easy part. Area equals length times width. That's the square root of 10 times the square root of 40. That comes up to 20. So the area for this one is 20. And the perimeter is 2 times L, which is square root of 10, plus 2 times W, which is the square root of 40. And what we end up with for that one, that would actually end up being 6 radical 10. And remember, for now, use the calculator for this work. I'm going to teach you more in module, I think it's 14, about radicals and roots. But for now, the calculator will simplify those for you. So our perimeter is 6 radical 10, or 6 times the square root of 10, and the area is 20. Okay, triangles. Area of a triangle is 1/2 base times height. And for the base, you can use any of the 3 sides of the triangle. What you want to do once you've picked which side you're using as the base, imagine, base means bottom, so imagine you're going to lay the triangle flat on that side, and then the height is the distance from the bottom to the very highest point on the triangle. So I give you 3 pictures over here if you look at them to the left. This first picture right here, this is probably the most standard picture. The bottom of the triangle is the base. The height is kind of this imaginary line going down the middle of the triangle. That's the height of the triangle. Now this picture here on the bottom is interesting because the height is actually outside of the triangle. When you have one of these tipped over, leaning over triangles, I laid it on one side and made that the base, but then the height is the distance from the top of the triangle down to, like, imagine that's the ground. If you're laying the triangle on the ground, the height is the distance from the top of the triangle to the ground. And then up here on the top right corner, I gave you an example. It's actually almost the same picture as the first one. It's just tipped over on its side. And that's just to show you the base doesn't have to be the bottom side. You can use one of the other sides as a base, but then imagine the height going perpendicular to it. All right. So let's find area and perimeter of this triangle. It's actually going to be easier than our last example because it's not in a coordinate plane. We don't need distance formula. We got this one. So for area, our formula was 1/2 base times height. And for this question right here, I think it's set up perfectly where I can use this number right here for the base and this number right here for the height. So it's basically just 1/2 times 18 times 7. 9 times 7, that would be 63. So the area ends up being 63 here. Now for perimeter, all we have to do is add up the sides. So I'm going to use the 18 again. I'm not going to use the 7 this time. This is when I use the 9 and the 13. So I didn't need the 9 and the 13 for area. I do for perimeter. So perimeter is just going to be 9 plus 13 plus 18, and that would be 40. Yeah, so perimeter is 40 there. Real quickly, while I have this on the screen, I'm going to erase these circles for a second. Oops. The reason that the formula for area of a triangle is 1/2 base times height. Base times height is kind of like length times width for a rectangle. Every triangle is actually half of a rectangle. If I draw this, it's called an inscribed rectangle going around the triangle like this. you can see that this little left side of the triangle right here that I'm coloring in, that's exactly half of that left-sided rectangle. And this triangle right here is exactly half of the right side of the triangle. Because we're taking a triangle, or we're taking a rectangle and we're cutting it half diagonally. So if the red is half of that right side and the blue is half of that left side, or backwards, left and right, you can see how the triangle is actually half of that rectangle. Well, that rectangle, if I ask you to find its area, this is 18 and this is 7. That's the height of the triangle. So the rectangle would just be 18 times 7. The triangle is half of that. 1/2 base times height. Okay, the last thing is a circle. Our formula for area of a circle, not rectangles. This is not rectangles anymore. This is a circle. Formula for area of a circle is area equals pi r squared. Pi is a number. You might have, I'm sure you've seen it before. You probably have heard it's around 3.14. That's it rounded off. The actual number actually continues forever. If you're ever going to use a question with pi for our class, use the class set of calculators and use the pi button because it'll be exact. It won't round it off to 3.14 and you'll get a more accurate answer. The circumference of a circle is 2 pi r. So those are two formulas you want to know. They're pretty similar, so don't get them confused. Area is pi r squared. Circumference is 2 pi r. And r is the radius. That's the good thing about circles. Like a triangle has 3 different sides plus the height. There were 4 different numbers in that last question. We had to know when to use what. Circle has a radius, and that's it. If you know the radius of a circle, you can find its area and circumference using just that one number and these two formulas. So for our last example today, let's find the area and circumference of this circle here. And notice I did make it a little bit tricky. I didn't give you the radius. See that number 16, that crosses the circle all the way. And the radius of the circle only goes like this. That red part is the radius. What was showing, the name for it is called a diameter. And if I ever give you the diameter and you need the radius, just divide it by 2. So the picture was a circle of diameter 16 centimeters. What that means is the radius is 8. And that's the number I'm going to use for this problem. Now once you realize that, I said it's real simple. Area of a circle is pi r squared. So I do pi times 8 squared. 8 squared would be 64, so it's basically 64 pi. You can use a calculator to get a decimal for it. You could leave it this way, I'd be fine too. The answer is 64 pi, or it comes out to pretty close to 200. Now for circumference, we have 2 pi r. So I'm going to do 2 pi times, and then we put an r for, we're using 8 for radius for both of these. 2 times 8 is 16, so you basically get 16 pi. And again, you can leave it, you can multiply it out. I think it comes out to maybe close to 50, 49, something like that. But that's it. It's two very simple formulas to use. Pi r squared or 2 pi r, just know the radius and plug it in.